Hello, dudes and dudesses. Let's begin programming. Or are we really going to be programming? The reason you're seeing Draw.io and not Unreal Engine 4 in front of your face or on your monitors, to be more exact, unless you're in the future and you're looking at this in hologram, which would be cool, is because we're not going to be doing anything in Unreal Engine 4 per se. Okay? You see, both UE4 and really any other gaming engine, so to speak, is dependent on a particular set of rules which are defined by a framework. Now, in this case, for example, UE4 is written in C++. And C++ is an object-oriented programming language, okay? It's a paradigm that means that everything is considered an object. Now, this might sound very confusing to you because what do you mean everything is considered an object in programming? I thought programming was all code in this. Now, the reason we're doing this in Draw.io and not in Unreal Engine 4 is mainly due for two reasons. First of all, we won't be going over C++ at all. Zero. We won't write a single line of code. We will only be using blueprints. That's one. Number two is because blueprints don't really have the overhead that they used to have at the beginning of the engine's life cycle. Meaning that blueprints get compiled into C++ anyway, so whatever you write in blueprints, you could then examine in C++ and vice versa. Which means that really it doesn't matter in what you're programming as long as you get the results that you want. Make no mistake though, in both cases, it is still programming. Whether you do it in a graphical sort of visual way or do it using an IDE, which by the way stands for Integrated Development Environment, which is kind of like a leveled up, like a super version of a text editor, or like you can obviously program in Notepad++, it just works fine. Of course, you have to compile the thing. But we will go over some of these things in a little bit later. I wanted to simply give you an idea of how programming works. Reason for that is because when I was learning initially, I had a lot of trouble figuring out what people actually wanted to tell me. So I watched all these videos about, there's Java and there's C++ and there's C# and there's like a bunch of others, PHP, etc. And really I couldn't understand. They were all trying to convey an idea to me, the abstract idea, but they all failed miserably because everybody started with a text document. Everybody started talking, oh, well, let's create a class. Let's do this. And yeah, I mean, once you understand the idea, it is very simple to learn. They're great learning tools when you know the abstract idea behind it. But I couldn't grasp the abstract idea because, well, first of all, I didn't have a teacher. And second of all, every time I read something on the internet or a blog post or whatever, they always would start with, well, let's write a class. Let's have a class. Let's say I have a class of a car or something. And this class has such and such properties, and we can expose these public variables, and then we could, private variables, then we get these public functions that would basically get getters, etc. And you suddenly it all turns from figuring out how the whole thing works into trying to understand what the guy tries to write in the first place. Now, once you of course understand that, you can extrapolate essentially the idea. But I'm kind of going to boil it down for you guys because, first of all, it's not necessary to learn C++, and because you might already know another language, although I highly doubt that, because if you did, you wouldn't be watching these videos. And also because it's important to understand the idea. Once you know that, you can learn any language, okay? So syntax usually is different depending on the language, but they have a lot of similarities. Some of them are vastly different, but at the end of the day, the idea and the methods are the same. That is, of course, in OOP. There's other programming paradigms such as functional oriented programming, which is like an open source development type deal. This is a new idea. F#, well, it's relatively new as much as programming is concerned. Code is fairly old in general. But this F# thing is hopefully it'll be a thing in the future because it's a very powerful. It's probably one of the most powerful programming languages out there. I mean, they're high level, but they have a lot of, like, you could drill down on them as far because of their functionally oriented. So you could still use the OOP ideas that I'm going to teach you here in your let's say maybe 10 years from now, C++ is deprecated and everybody uses F#. The ideas of object-oriented programming that I'm going to present to you here right now will be relevant and usable in in F sharp just as easily. That's the beauty of the, of F sharp, for example, or other functional, well, not other functional, but F sharp in particular, that you can still use the OOP paradigm within it, and it'll still work. So you got a lot of options there. But it's relatively new. It's only 3, 4, well, maybe 5 years old or something like that, and as of now anyway. And it's been open source, but it hasn't actually gained momentum yet. But it's great. It's great. Now, the reason we use object-oriented programming, and the reason I'll be talking about a high level, we'll be using it in a very high level. And when I say high level, I don't mean that it's very high level in the basic terms. So if we look at it this way, if I say that, oh, we'll be using the high level, which would be this particular point, this is a high level, you might say, oh, very high. Yeah, that's very high, but really you're only exposed to this much. Okay, that is high level. There's a lot of stuff you can't do at high level, mainly due to the fact that it all rests upon what's written on the mid level, and the mid level is everything that is resting upon the lower level. Now, obviously, it's a pyramid, right? The tip of the spear, so to speak, would be what we're doing. The body would be the mid level, and of course, the low level would be the kernel. Now, low-level programming is much more different. Actually, all these levels have different programming sort of methods, and obviously the higher you go, the easier it is, because over here you have all the tools, all the tool sets, SDKs, etc., all the libraries that you need to build anything you want with this foundation here. Obviously, this foundation is not what we're going to be writing. Game development used to be difficult because you had to actually define all this shit yourself. And the language used for that gets more complex, or actually not more complex, more difficult the lower you go. Because the lower you go, there's less to work with. You need to start building it up on your own. Obviously, at the bottom here, you got the kernel, which basically is the interface between the hardware and the software, right? So you're one step short of basically writing with zeros and ones, okay? Now, the reason code is handled and needs to be compiled is because the computer needs to read it, and code is readable in binary. Now, unless you are a binary savant, and even if you were, it take you ages to type anything, since a sentence could be anywhere between 1,000 and upwards, of course, in terms of sort of zeros and ones. You use sort of regular language. Now, since there is a language, but you can't really describe everything in English. You need to have sort of a framework to define that. So that's why we have a framework. This would be the engine in our case, and the top of the, this arrowhead would be what we'll be actually working with. Now, that's not to say that you cannot dive deep down. That is because Unreal Engine 4 is open. The source is open for everyone to play around with, so you can really just download Visual C++ or something, Visual Studio, and just dive deep into the C++ code, and you can change everything in the engine itself. Obviously, it won't be propagated across everyone else's distribution, but the point is that you can branch off something off of Git and play around with the code, and maybe that's how the engine, by the way, has grown so much, because everybody makes their own little bit. There's movie studios that program tools and techniques and rendering stuff specific for movies, and the Epic team decides, oh, that's a great tool, let's dump it right into let's put it in our engine so that people could use it for whatever it is they desire. And then there's the other guys that were making maybe live sort of like motion tracking stuff, or maybe some tool set, some highly defined specialized toolkit for grass maybe, or some foliage, or maybe level of detail, or I don't know, whatever. Or maybe it's just a random enthusiast, just some guy here at the bottom, or maybe some guy with an idea here that just figured, hey, this would be cool if it was possible, or some guy who thought, could I do that? Maybe the audio engine needs tweaking. It doesn't have to be visible, of course. The point is that all these people, they're contributing to this engine, not to mention the Epic team itself, and this engine is really growing fast. Okay, so what does that mean that the high-level the high-level programming that we're going to be doing? Well, Blueprint is generally high level. So, for example, you might want to change some fundamental thing in Unreal Engine 4. For example, gravity. Let's take a look at gravity. Now, of course, gravity is exposed as a parameter, basically, and you can set it up any way you like. You can change the direction of the vector. You can change the magnitude. But if it wasn't available, you would have to actually go into the engine and look where gravity is set up and say, okay, this is where gravity is. I'm going to expose this for other people to be able to tweak, instead of it being like a defined 9.81, for example, right? That would be what you could do. Obviously, that's not the case since it's done, and there's no reason not to have it exposed. But I'm just saying, if you find something that you don't have in the engine, you either write it yourself from the ground up, or you just simply expose it for yourself, of course, because obviously it could be dangerous if somebody uses, tweaks something and it breaks the whole project that someone doesn't really know what they did. Okay, that being said, that's enough rambling about how Unreal works and what high level is. We'll be talking about the actual programming sort of paradigm and the idea behind it. Now remember, we're going to be talking about object-oriented programming, and in that paradigm, everything is considered an object. Now, for me, this was really difficult to grasp, not because I couldn't understand that everything is an object. I just couldn't imagine how that would translate to programming, because all I saw at the time was, these, sort of letters and, functions and commands and this and that. I understood what they did. I just didn't get it why they were there. Okay. So programming is just an idea, generally speaking. Now, let's go ahead and create ourselves an object. I'm going to take this rounded box. I'm just going to put it here in the middle. And we're going to say that this is an object. And that is amazing, right? This is an object. Now, you could do the same. You could basically write something. Let's say, oh, I've got a bed. And we would say that this bed is an object. And I'm not talking about the actual representation, what the words mean. I'm talking about this actual string of these 3 characters. We could say that this is actually an object, like a real world object. Okay, remember, I'm not talking about the bed. This, for example, is also an object, right? It doesn't have to be named anything. As long as it's something, it is an object. Okay, I hope that is understood, right? Whatever you have, it's always an object. All right. Now, that being said, what do objects possess? Well, objects possess characteristics, right? I mean, you can describe any object that you currently have in your vicinity, and hopefully you can describe any object that is given to you from external situations. Let's say you get a new piece of technology, but you can describe it, how it feels. Is it heavy? Can it fly? Can it shoot? When it shoots, well, how big is the recoil? Does it shoot at all? Like, what kind of object is it? Is it rectangular, square? So there's all sorts of different, object properties. Let's put them that, properties. But you always start with something like overarching. Now, this kind of object is called a generic object because, well, it's generic, really. It can represent anything. It's an abstract sort of object, right? This could be anything. Right? This could be the object itself. So let's say this could be a car. My object is now a car. This could be a bed. My object is now a bed. Could be a bench. Right? So there's loads of different ways this object could be represented. Therefore, it's actually called a class. Generally speaking, this could be sort of your highest. Now, that's not to say that anything that's called a class is the highest possible branch of objects. The point is that if we call this class, let's say this class is a vehicle. Now, I'm going to ask you something. How many vehicles have you seen throughout the course of your life? Chances are pretty much a lot. Okay? Hopefully, anyway, unless you're like 2-year-old savant or something. You've never seen a car in your entire life. The point is that you've seen a lot of vehicles. Now, by vehicles, what do I mean? Do I just mean the cars? And what about bicycles? What about planes? Planes are vehicles, right? I mean, technically I think they're vehicles. What about trains? Anything that is a means to transport is a vehicle. Really, anything that operates based on an engine or moves or gets you from point A to point B is a vehicle. Okay, it's a method of transportation. In fact, I think if you had a jetpack, it would also count as a vehicle. Now, and by the time you're watching this, if you do happen to have a jetpack, please clarify in the comments. Unless, of course, Google has gone bust, which I don't know how it would happen. But So we got a class which is a vehicle. This is a generic object, okay? This vehicle can be anything. Again, I hope this is very clear. Now I'm kind of trying to hammer this in because you're gonna see why. We're gonna go more and more granular as we go further. Now let's say I want to define another vehicle. Okay, let's say this vehicle has a particular set of properties, right? It has, let's say, weight. How am I gonna represent this? So let's put I don't know. Let's put this here, right? So this vehicle has a particular set of properties. It has weight, and it has, everything has weight, right? Because presumably, well, not weight, we should call it mass to be more appropriate. Weight is the act of gravity. Mass is basically how much matter you have. Then it would also have presumably a volume, right? So how much space does it take, right? It could be massive, but it could be a neutron star, or it could be massive and could be a galaxy, right? So in terms of vehicles, it could be something as small as well, there's really not that many. Well, yeah, like if you compare a tank to a bus is bigger than a tank, but it is not as massive, right? So that's how you have the volume bit. Then since it's a vehicle, it presumably moves, so then it also has speed. I'm not, obviously we can go further and further. You can define as many generic properties as you want, but in general, these properties would be appropriate to have, to be assigned to a vehicle. Now, out of this point, let's say we want to define a, well, since we're on the tank notion, let's talk about tanks. Well, no, I don't know tank. Maybe a tank will be fine. Yeah, let's go for tank. Or cars. Let's go for cars since they're the most generic vehicle out there. Tanks are going to be a little bit too difficult to draw parallels across, although it's definitely possible. We'll replace this with a tank later, all right? In fact, we will use a tank. There we go. I have an idea how we're going to do this. So first of all, let's create another car. I'm going to create a car here. I'm going to say this is another vehicle, right? Which is going to be a car. Now, a car, again, is a fairly genetic vehicle, isn't it? Like, how many types of different cars you know, right? But a glider is also a vehicle. It doesn't have an engine, right? So you could say, well, I will inherit all of these properties that a vehicle possesses, right? Since a car is a vehicle. And I'm going to say, well, this car has a mass, has a volume, and goes with at a particular speed, okay? However, it also has some other stuff, such as an engine, right? A car has an engine. Now, obviously, you could get something more generic. Obviously, not all vehicles have engines, although technically maybe they do. It depends on how you want to define them. It's up to you, right? That's the beauty of programming. If in your world vehicles don't have to have engines, if the definition of a vehicle in your world is anything that moves, anything that gets a person from point A to point B, then it shall be so. So you're kind of the creator of your own rules in this case. Now, in my world, anything that gets you from point A to point B is a vehicle, right? It could be a glider, a parachute, whatever floats your boat, anything that helps you propel yourself other than your legs. So a car will have an engine, right? So we're going to get another one of these. I'm going to put it on the right side here. And I'm going to say, well, what does a car have? An engine. It's got tires. Well, technically it's got wheels, right? And these wheels have tires. So maybe you have a tire class specific for that car, because there's many types of types of tires. There's many types of wheels too, right? Let's just say tires, right? Now these tires could be inheriting from an overarching wheels class. Now, obviously, if you had something like this and you had created a wheels before, right? Wheels. Now this class would have a particular set of properties, right? Because everything must have some kind of properties. Otherwise, what the fuck is it, right? It can't be anything. So these wheels have rims, right? They have tires. They have, well, volume or sort of size, right? They have a particular size. They have anything. And then you could have another class called tires, and these tires would have grip and this and this. See, you can go as granular as you want. It depends on what it is you're trying to accomplish. Generally speaking, you should also choose the language that you're going to learn. I mean, I'm talking about actual, like an actual language with syntax and all that, such as C++ or Java or whatever, not just blueprints. Although blueprints sort of do have their own kind of little syntax, but they're a lot more lax. The point is that depending on what you want to do, you need to choose the particular language. Now, you wouldn't be, of course, writing web applications in C++, right? Because even though C++ is extremely fast, it's mainly used for software. You wouldn't be, for example, writing a game in Python, or a game engine in Python. That would be idiotic, right? I mean, it's still a programming language. You could still probably do it, but it's still stupid, right? So just take my word for it. You don't want to write a game engine in Python. Okay, that being said, you don't have to always define these things because you can give properties to them on the fly, right? So I'm not going to say that I have wheels. So I'm just going to say that my wheels are over here, and I will define everything about these wheels later down the line. So let's just say, well, I already have wheels. It has an engine, has wheels, got doors. Well, not all of them have doors. Well, maybe it's got aerodynamics, or it's got a shape, right? So it's got a body. Although maybe that should be in the vehicle, but every vehicle has a body. Does it? I don't know. Let's just say, okay, let's just say doors, all right, for the sake of simplicity. Now, all of these are objects in and of themselves. I mean, you either define them here, and they are part of the car, and from now on, everything else that is part of that is a car will have these. And you would have to define them there as well. Sorry, you won't have to define them there as well. Or you have another class that adds several more options. So you could go really granular. You could go all the way down to nuts and bolts this way. As you can see, we got a car now. This is another class, right? Class, car. It's got engines, wheels, and doors. It also has mass, volume, and speed. Okay? Then you could say, well, I want a Ferrari. So let's create a Ferrari. There we go. I got another rectangular here. And I'm going to say that this is a class Ferrari. I think that's how the thing is written. I hope they still exist in the future. Really nice cars. Beautiful stuff. So a Ferrari is a car, although they probably do have other things, but we're talking about the car Ferrari. Okay? Now, Ferrari has several different things going for it, right? Now, you could have defined this as part of the car, by the way. This is entirely a choice, but I'm going to say that Ferraris have their own models, right? There's loads of models of Ferraris. There are also brands here, okay? So I'm going to say this is also it's got a brand. Although if you define a brand as a sort of a property, you're going to need to give it like kind of like a thing, right? It could be the same. You could actually have a property here called brand, have a list of brands, and this Ferrari would be one of them brands, and you could actually end your whole setup over here on the car. But since I want to create a class Ferrari, since I want to go more granular, I'm going to remove the brands from here. I'm not going to keep it over here, although it is generally something that I can use. However, there's no need, since I'll be creating separate Ferrari class, okay? Unless, of course, I simply want to have a racing game where I'm going to say, well, there's brands, and you get to choose from all these brands, and then these brands have their own little breakdowns in terms of models. Completely fair, since each brand would have to be its own thing. Okay, so I'm just going to delete this here for now. But you could, like I said, you could easily add this here. Okay, now next we've got the models. A Ferrari has a set of models, and these models you could break them further down. They have a set of years, and you know how many models per year, right? But I'm going to stay at models. It's got a class. And by that, I mean, is it a sports Ferrari? Is it a, well, is there any other kind of Ferrari? I don't know. But let's say there is, all right? Let's say there's a combat Ferrari, there's a sports Ferrari, there's a badass Ferrari, there's Survivor Ferrari, there's a fucking Jeep Ferrari, right? We could just say that all these things do exist. I'm going to say they're part of the Ferrari class. Now, a Ferrari in this case would have loads of stuff for it, going on for it. It would have mass, volume, speed. It would have an engine, wheels, and doors. It would also have a model, and a class, right? And you could say they could also have a year. Let's just say a year. There we go. So which year, which class, which model, what kind of engine. You could have obviously further breakdowns. So is it a V8, a V4, a V6, a W? Is it like an inline, right? Then you've got the wheels. Is it like a sports wheels, right? So loads of these different properties. And you can easily mix and match between them. So for example, you could have a set of doors, and these doors would have their own little thing, right? You could easily pass them in as a type. Notice that everything here is an object. In other words, everything really is a class, okay? I might have defined somewhere else, I might have said, well, we've got ourselves a class that is engine class. And then I'm going to say, well, there's another one called wheels, right? Now, the cool thing here is that, for example, in this case, let's say I go for several different properties and say, well, there is a V4, a V6, a V8, a V12. Well, there's a V10 and V12, and that's like we go W, right? W12, and there's a W16, and there's an inline 4, and there's all sorts of different ones. Or I could say, well, since this is an engine and we have a configuration of that engine, so it's going to be either a V, a W, an inline, or I think there was another one. Was there? Yeah, a boxer, sorry. So it would be a boxer. So let's say these are the 4 main types, for example, right? And then you would have a class, another class. Let's say we duplicate this again. This class would be a V, like so. I hope this is starting to make sense. This would be a W. Oops, W. This would be an inline, and this would be a boxer. Okay, so as you can see, you can really break down a lot of stuff. So this is the engine here, right? This property. Again, if you don't want to go so granular, you could just say there's only one engine, right? There is no other types of engines. You could do the same for the wheels, for the doors. You know how aerodynamic they are, for the body, for the mass, for the volume, for the speed. But generally speaking, in my case, let's say I'm gonna presume that there's only one engine, right? And in my world, the engine simply has one characteristic, and that is size or speed, right? Or it's simply a type, right? It doesn't have any impact. It's simply a word, a letter. It doesn't matter to me, right? I'm gonna say that this is an engine, and there is only one engine, nothing else. So that's a property of the car. Then you've got the class Ferrari, and you could even go further down. Now you might think, well, how does that, like, what are you trying to explain here? What I'm trying to explain here that these two things have common properties with this, okay? All right, so just as a car inherits from a vehicle, Ferrari also inherits from a vehicle. This is called, by the way, inheritance, right? Or also, like, there's also polymorphism, which allows you to address, for example, if I were to do something with the mass of a Ferrari, or maybe anything else with a vehicle type property here, then I would say, well, this is kind of polymorphism because I just defined a class called Ferrari, but I'm working on it as if it was a vehicle, right? However, you cannot work on a vehicle as if it was a Ferrari because a vehicle does not possess models, classes, years. You don't know what it is. That's why I'm going to show you another thing. Here, we're going to create, I'm just going to keep duplicating these. It's much easier. This is a tank, okay? Now, a tank has, for example, also has an engine, hopefully, but doesn't have wheels. It's got treads. Treads. Not sure which way it is. It doesn't have a door. It doesn't have doors at all. It's got hatches. Presumably, it also has guns. Or weapons in this case, since there's different types of weapons. So that's a tank. Now a tank is also a vehicle. It gets you from point A to point B, right? It also has armor, for example. So its body would have, maybe you would be able to define a particular way, depending on what you really want to accomplish. So you would either have an armor. Why can I not get this to match in terms of size? Because this one is longer. That's why. There we go. I think it's perfect enough. No, there we go. Come on, there we go. Okay, delete that. So as you can see, these properties are, only for a tank. They would not apply for a car. This is also a class. All of these are classes, right? All of these are objects. Now I'm going to duplicate this again, and I'm going to say, well, I will use this is going to be a class. I don't know. Fucking tanks. Only the World War II tanks come to mind, but I don't want to do that old shit. I want some new. So let's say in the future. Well, actually, let's use Warhammer 40k. This is a Baneblade, right? It's a big-ass tank with a big-ass weapon. It's not like every other tank, right? It's a huge tank. But it also has treads. So it's got an engine, it's got treads, it's got hatches, and it's got weapons. What kind of weapons does it have? Now, here's the question. I'm going to duplicate this, and let's just say our Baneblade, and really every Baneblade, has engines, treads, hatches, weapons. And it also has characteristics specific to the Baneblade. So it's got a big-ass gun, or main gun, blaster, whatever. It's got like machine gun turrets, right? It's got, I don't know. And let's say it's got mini bunkers, right? Whatever. So let's say it's got all these three things. Now, let's compare these two classes. Both of these are objects. Both of these have engines, for example. Now, you could say that this engine and this engine is one class, okay? So follow me here. Let's begin from the top. We have a vehicle. Now, we could say that a Ferrari is also a car, and therefore also a vehicle. We could also say that a Baneblade is a tank, and that is therefore also a vehicle. These things have these properties in common because they inherit from the main class of vehicle. However, a Baneblade and a Ferrari, they have nothing in common. Okay? Nothing in common. Except the fact that they have vehicles and they have engines. So it's not nothing, but it's you get my idea, right? Now here's the cool bit. You could say that there is another class here, like the previously defined engines. And the cool thing here is it would not actually inherit. These two things do not really inherit from the engine class, right? There's nothing to inherit from here. An engine, and let's say engines, just engine regular. An engine is just like a vehicle, a generic class. And you could break this down way further down. You could go all the way down to pistons and firing spark plugs, right? You can break it down to a diesel and a petrol, right? Diesel's got this, petrol's got that, but they've got some stuff in common. For example, the way they're shaped. So it's a huge class. Again, engine. But notice that it's still being used. We have an engine in both of these cars. Both of these classes. One cool thing here is that these don't necessarily have to be this class. Okay? If they don't have any properties, if they're a simple, let's say, number, right? So this has one engine and this has 20 engines. I was going to say engines for some reason. Okay, so a car has only one engine, whereas tanks have many engines, right? So in this case, they have nothing in common, right? Maybe it doesn't. For our purposes, we don't care what kind of engines they use, as long as we know that the number is different. Okay. Now, if you want to define some extra stuff, you could definitely say, yes, this is the exact same engine as we're defining in this class. Right? And now this engine here, it has its own little, subclass of, let's say, a V4 or a V8, just like previously defined. And it's got its own set of properties and parameters. And you could use that. Let's just say we're going to use that. I'm going to say that an engine has its own weight. So let's just say here we've got the engine is heavy, so engine has weight. And you could define, again, easily, even with these properties, you could still define 10 engines in a tank, right? It's just that each engine, for example, would have weight, which would, via a function, you could say, yes, this weight actually is added to the mass, to the mass of the vehicle, right? So the vehicle has a mass and the engine has a mass, and then you combine the two. It also has, let's say, torque, or let's say just output, because it, like, I don't know, if maybe it's not the torque, maybe you're outputting some kind of plasma shit or whatever, right? You could say this is a kind of generator or whatever, because really there's no really very little difference between an engine and a generator. Like, actually there is none, technically speaking. Well, there is. I mean, the engine transforms energy into some kind of, well, it transforms energy from one point to another, whereas a generator generates energy. It is still transfer. Look, the point is that you can actually do a lot of stuff using this kind of workflow. And you will actually notice here that we're using a different, not an inheritance type workflow. We're actually using a like opposite of inheritance, which would be compilation workflow. Composition, sorry. So this is a composition type workflow where we grab something which is basic and then we build something with it. So if we had, let's say, these engines here, these classes here, there were doors. We got class doors, and we've got class, let's see, doors, and then we've got class wheels. Well, wheels, or better yet, actually, let's do it another way. Let's define something else. Body. We've got a class body. It's a much better way to present this. Class body and class driver. No, a user. Right? So as you can see here, we've got ourselves a bunch of these classes. And we can compose an object, right? In this case, a car, because that's exactly what we're doing, right? A car has a particular set of properties, and if each property is its own class, it's kind of like we're making a car out of these parts. It's not that a car possesses these parts. We just made the car with these parts. So we could say any combination of a body. What am I doing? A user class. This needs to be class. So anytime we have a user, a body, and an engine, it could be a car, right? So that's how you would go about it, right? Let me just do this in a little bit more visual manner, because I do think it's important to understand the difference, and that it's obviously you work with both of them. You don't just keep inheriting stuff. Let's just say, oh, an engine, right? It breaks down into this. Oh, this, and then it breaks down into that. You just keep going further and further down the line. The problem, I'm going to highlight the problems with both of these workflows, by the way. Now, first of all, we've got the class body, the class user, and let's still use a, well, what else does a tank have, for example? So we forget about this for a second. Let's just use a tank, right? Let's try to create a tank. So I'm going to duplicate this again, and it's got a body, a user, it's got power, okay, and then you've got, oh, I don't know, you've got range. Well, this is not technically a class, it's a property, but let's say it's got power, it's got weapons, obviously we have them here again. Then it's got, well, obviously treads as well, but well, let's just keep it treads. Now the difference between this tank here and this tank here would be as follows. Let me just create this tank. Do we have a tank here? Tank? Is there a tank? There is no tank. Oh, whoa, what? There is a tank. There we go. So it's got treads, it's got, yeah, all right, that's what I'm talking about. So a tank is a composition of all of these objects. So we got our treads here, presumably like so, and presumably this is our body here. So we need to actually move this guy out and grab this thing and move it to the body, and then move this thing out as well. Okay, so as you can see, we have our body, which represents the body of the tank. We got our treads, the power, which represents our kind of engine. I'm going to put this in the ass of the thing, like so. It has a weapon, which would be this particular little neat thing, like this, and then it's got a user, which hopefully would be somewhere in the middle of the tank. So I don't know, like something like this. As you can see, we've just composited a tank out of this, out of these sort of classes, right? We've defined a set of classes. We've composited a tank out of them. So what are the benefits and the problems with each of these things? Because remember, you have a class power, but this class could be inheriting from an overall engine class. You could say, oh, our engines here are actually, you know, these are the outputs that they have, and power is just one of them outputs. Now the problem with this, the first workflow, is the fact that when you have something inheriting from another, whenever you change anything in this vehicle, for example, you will actually change this for every single class that inherits further down. So if you change a vehicle's properties, for example, mass, volume, and speed, and you say, well, my vehicle no longer has speed, or one of the most generic parameters don't no longer exist. So let's just say, well, every vehicle from now on will have lights, right? Bulbs or headlights, whatever. Every vehicle from now on will have lights. Now this will propagate. That's the beauty of inheritance, because the moment you add something here, you add it everywhere else. However, you also have to define it everywhere else after that. In other words, initialize it, right? So a car's lights would be red, green, and blue. The tank would have basically no lights, and Ferrari would have loads of lights. Baneblade would presumably stay sort of, you know, dark. The point is that maybe you can turn them on and off. The point is that they have to exist. It could be a glider, a parachute, a freaking skateboard, but it must have lights. So if you add this here, you will break a skateboard, which is a vehicle, right? If we create a skateboard vehicle, you will break it by adding lights to it, because it just doesn't have lights, and you realistically probably wouldn't be adding lights to it. All right. Now the beauty, of course, again, you're inheriting all of this stuff, so you're kind of saving yourself a lot of work by saying, well, my tank has mass, volume, speed, light. So you would actually have to, instead of, if you didn't inherit this, you would have to write these over here like this. So you have to have all of these here instead, if this was just a tank on its own, as we have something here, right? Whatever this tank does not possess, we need to create. We can't just, you know, change something down the line and be like, oh, right, this is our tank. Now, as you can see, this is a successful example of how to use both of these methods. You have a class, which is an engine, which then is being used in two other classes to create them, while these classes inherit the more generic, you know, the more common stuff from the vehicle. So anything is massive, therefore everything possesses a mass, and therefore it's generic, right? Not everything has an engine. Therefore, even though the engine itself is a generic engine, not a particular engine, it can be used in anything that supposedly has an engine, right? And that's the beauty of it, because in the first case, if you want to change something over here, you actually, in the composition case, if you want to change something, you have to go hunt down which bit you actually have to change. Then you have to go in and change that, you know, and if you need to add something, you need to actually add it over here, for example. And the problem with this one is that it needs a lot of interfacing. And by that I mean an interface is essentially a contract between two classes, all right? So if you have a class, again, in a composition scenario, for example, if you have a class which would be, let's just say, let's just grab a shape over here. We have a circle. This is our one class. This would be class A. And actually, let's go ahead and further increase this. So we have a class that is a painting, right? Sorry, an interface that is a painting. My bad. You'll see the difference now. And we've got two paintings, right? We got Mona Lisa. Actually, let's use I don't know. Is there a painting? Oh, there it is. I believe this looks like a little bit like a painting, doesn't it? Oh, no, I think that's a tank. Let's just say painting. Oh, there we go. So we've got two different paintings, right? One is like this, and the other one is the hell, and the other one is like this, right? Now, both of these would be composition classes. In this case, you'd have a moon class, for example, right? If you're using composition, this would be a moon class. This would be this. This would be that. The only way you could actually define them as paintings without having them inheriting stuff from a painting class, right? Just think about this for a second. You could inherit it. You can inherit something, or you could build something with composition. If you want it to have anything in common, sort of like inheritance, but not entirely. In other words, you don't have to have. It doesn't have to have a mass. It doesn't have to inherit everything. It only needs to have a specific set of properties. It can be something entirely different, right? Not a painting, for example, a sticker, right, or like a tattoo. Okay, the important thing is for a painting, it has to have I'm going to put it over here. So anything, in order to have an interface between paintings, or in this case, pictures, actually, to be more precise, picture interface, a picture needs to have an image. Okay, it needs to have something visible, so it has to be viewable, right? So that's, for example, something important that you might want from your image, anything to possess. Then it also needs to have, let's say, resolution, right? So how good is the quality resolution? So how good the quality of the picture is. All right. So let's say these are the only two things that you need to have in common between anything that is presumed a picture. And if these two things are pictures, then they are contractually obligated to possess these functions. Now, in the inheritance sense, these sort of properties would be defined by whatever you inherited. However, in an interface, you are obligated to define these yourself, right? So you are saying, well, I want to be a picture. And the interface says, well, if you want to be a picture, you gotta have an image and you need to have a resolution. Without those two things, don't talk to me. Okay, so it's up to you to say, all right, so this picture has this particular image and this particular resolution, right? You have to define them in the actual class here. It's also possible to, of course, use different classes, and you could do the same really anywhere over here. So inheritance kind of removes the need for interfacing, since, you know, if you want to interface with something, you can just inherit it, right? But that, of course, depends on the situation. Now, in this case, of course, we have a picture here and we have a picture here. Both of them need to have an interface. Need to have an image resolution. The cool thing, of course, with the interface is that once they have them, you could simply say, well, every picture from now on will be black and white, and you will change everything, every picture that is connected to this interface, to black and white. In theory. So that's pretty cool, I think. Also, it saves you a lot of time, right? It's because you get the good stuff from inheritance, but you don't get the sort of disastrous results. Because the deeper you go, you see, the problem with inheritance is once you go a lot further down the line, like if you go really a lot further down the line, you really start losing your sort of, like, it's just a question how granular you want to inherit before you stop and you start compositing stuff. Now, generally speaking, in Unreal Engine 4, you will be compositing most of the time. You will be inheriting from time to time, but generally all the inheritance, all the inheritances have already been set up for you, right? There's actors, there's like pawns, characters. So there's different inheritances, and each level has less and less sort of generic options. Okay, so the further down you go this tree, the more concrete you become, right? The less flexibility you have in this particular class. So Ferrari can only do so many things, whereas a car could be so much more, right? A Ferrari can only be any Ferrari ever in existence. A car could be any car ever in existence. A vehicle is pretty much any vehicle ever in existence. So as you can see, your options in creating a particular sort of object increase the higher you go in the inheritance tree. The lower you go, the more specific you have to be in your definition. All right. So all we have to do now is simply understand that there's two types of workflows, composition-based and inheritance-based. And of course, there's also sort of the middle ground, which allows you to use interfaces to sort of use inheritance. All of these three methods are usable between each other. You can use them at the same time. You could have, for example, oh, this is an engine. Well, in other words, for example, since this is an engine, let's just finish this picture here at the top, which is, I think, a good representation of how a program would look like. Let's say we grab this circle, and I'm going to say this is an interface, and this interface here will have, it will be called a, what's it going to be? A device. Okay, a device. So anything that is a device needs to possess a kind of, I wonder if I can like sneak this in over here, like so. Oh, I just created this, didn't I? Sorry, my bad. So let's just sneak this guy in over here and just make him a little bit smaller and just put him over here, well, over here, like this. Yes, yeah, so I'm going to send him to background, to back, and maybe put them all the way up here. And now I'm going to say every device needs to have fuel, okay? And be it an engine, fuel, and I mean like a fuel, like a source of power, all right? So fuel would be electricity, right? Batteries, whatever. So every device, in order to operate, needs some sort of fuel. And I'm going to say, well, okay, I need to just pull this down a little bit. Well, since every device has fuel in it, if you want to be a device, you need to have a fuel input. And therefore, once this actually is hooked up and you say, all right, I will perform your desires, and I'm going to say, all right, well, and that's the case, then we're good to go. For some reason, I'm not getting a really good lineup here. There we go. That's a great lineup. I love geometric lining up. So as you can see, this device now, this engine is now a device. Every time you could actually use it as, you can actually sort of address all the devices that you have and send requests, right? So let's say the fuel is gone all of a sudden, or maximum fuel, or cheat your way out, something like this, right? Obviously, it doesn't only have to be an engine. It could be a flashlight, or a lot of stuff could be sort of interfaced with this particular interface. Since it only has one requirement, you need to have fuel. Other interfaces have more requirements. You can have thousands of requirements. Well, thousands is a little bit overkill. You want to keep it as simple and as blocky as possible. So as you can see, programming is a lot like your personal approach, the way you view the world, really. Do you prefer to go with just something generic and then just breaking it down to something that is really sort of specific? Ideally, you would do that when you want to create many of the same object, okay? So if you want to create many vehicles, if you had a racing game, yeah, you would want a class vehicle. But if you only had a car, if you had, let's say, only a Ferrari, or even if you only had cars, you would create a class cars. You won't be making a class vehicle to then inherit for a car, to then inherit for a Ferrari. If you only had Ferraris, you would simply define a Ferrari, okay? So obviously, for example, if you made GTA, yeah, they got tanks, they got fucking jets, helicopters, all sorts of things. So they need a class of vehicle because they got loads of different vehicles. If you're only making a racing game that only got cars, no motorcycles, no drones, no nothing, then you need a class car. This is as high as you need to go on the generic spectrum. Generally speaking, in general, it is not a good idea to go super abstract. Because the more generic you go, the more definitions further down the line you need, and the more locked in your generic setup becomes. Because understand, the more vehicles I have, the more I have to be more and more careful when I'm changing something in the super class, like in the main class here, which is the vehicle in this case. In the composition-based workflow, you basically write down whatever it is you need to create, and then you create them, obviously the same way, such as this. So these things also have their properties, like in this case, for example, the body would have its own little, it's got a shape, mass, weight, right? Or you could inherit from something that already has these things, so your body would be inherited from whatever. Let's say you have a sort of a master class here, which would say, well, we've got, well, I don't know, this cube, right? So this would be your sort of parts. Everything here is a part, right? So your body inherits from parts, and the engine inherits from parts, and the treads inherit from parts, and they've all got the same thing. For example, material, what kind of material they're made of. Flexibility, how flexible they are, right? How much heat can they withstand, etc., 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 etc. So all of these things are entirely dependable on how you want to approach your workflow. I may have sort of gone a little bit too abstract with you guys, but I do think that this is the best way to start learning programming, at least object-oriented, because this is what I could not understand when I was presented with a list of commands. Okay, I mean, there's a lot of people that do this. They do this exact same thing in code form. For example, they use Visual Studio and they go into this IDE and just start writing down stuff. And at the end of the day, it's hard to just get it in the first time. So I spent about a week before I figured it out, which is fairly long for me. Usually I grasp things easier. So this is much easier to understand, in my opinion, and you should really get a good idea of essentially how programming works. Now, this is just the overview, right? There's loads more, right? Loads more. In the next couple of videos, we'll be talking about these if statements, arrays, and like all sorts of constructs, right? But like I said, I will not be writing a single line of code. I'll explain everything using this graph because I believe it's a much more visual representation of what it does. And I do believe that if you understand what this is, and with the next couple of videos, what I explained there, if you understand that, you could learn any syntax, any language in a fairly simple. Obviously, it will require some effort. You're not going to be, oh, I already know how to do that, right? No. There's different libraries, and these different libraries have different APIs, and so let's say for example you've been modding Skyrim, but you want to mod for Fallout. Let's say they're different engines, and these engines have different SDKs. SDKs, the standard software development kits, which are sort of huge libraries and tool sets, kind of, which allow you to modify stuff. By the way, a library. Look, we'll talk about it later in the next video. For now, just understand that you've got several approaches of creating a software, or really anything. So this is your overarching tree. Now, how you do these, so let's say you defined them, you've created them. Obviously, like if you were to write this, you'd need a constructor. This constructor would need a particular set of parameters, which is essentially a function saying, hey, whenever you create a car or a vehicle, you're going to have to tell me what kind of engine it's got, what kind of wheels it's got, and what kind of door it has. Or if you don't, it'll have this kind of engine, these kind of wheels, and these kind of doors. So generally, your constructor is literally a constructor. It builds whatever it is you're trying to. Well, you have to define it yourself, obviously, whenever you're programming by using characters. But in general, that's what you would do. You create something, and then it will require an input of whatever it is you're creating. Okay. That's it, guys, for this video. I'll see you next time. Really, actually, let's just hammer this one more time. Let's just hammer this down. 3 ways of making a software work. 1 is inheritance, where you inherit from your highest generic object or class, right? So your highest generic object is, in this case, a vehicle. You inherit further down. The further down you go, the more granular you get, and the more precise you get in whatever it is you're trying to describe, because it's not generic anymore. However, you also have an opposite option where you could be building stuff with whatever classes you have described. These 2 workflows are not mutually exclusive. You can combine them to have the most effective layout. Thirdly, you have a method of talking to different classes using a interface. Allows basically 2 classes to have similar functions, which allows you to essentially call them on every single class, for example. Because understand, if you have an image and has a resolution, you delete the resolution, or you globally change, sorry, you delete the image, or you globally change the resolution, this would propagate across every object of this picture interface. So this is a really huge time saver if you've got a lot of these different things, and you're trying to compile them and then control them separately. Whereas, of course, you could do the same in the inheritance. Okay? All right. I hope you got that into your head. If you did, great. Great success. If not, well, let's hope you get it in the next few videos. I don't know what to tell you. This is the simplest way I know that, you know, how to describe this sort of process. All right? Okay, this time for real. Bye-bye.